Welcome to our class. In today's lecture, we are going to discuss about the thermochemistry, which is part of the syllabus that encompasses both the thermodynamics as well as the thermochemistry. So let's begin with the definition of thermochemistry. The definition of thermochemistry is, before going to the definition of thermochemistry, we should look at the name thermochemistry. Thermo means thermal energy or heat, and chemistry means, as you know, chemical transformation. So whenever any chemical change or chemical reaction takes place, it could be assumed that it will be accompanied by the absorption or evaluation of heat, and the branch of chemistry or physics that deals with physics is basically came from the chemistry, or we can say that the mathematics is the basic part from which the biology, the chemistry, and the physics that has evolved, and there is a close relationship between the physics and chemistry. And that is why some books are named as physical chemistry. Okay, so we are omitting the term physics. Now we are using the term physical chemistry. So this is the physical chemistry. So we can say that whenever any chemical reaction takes place, then it will be accompanied by the formation, that means evaluation or absorption of heat. Whenever the chemical reaction is accompanied by such evaluation or absorption of heat, then the discussion of such kinds of transformation generally takes place under the branch of physical chemistry, is known as thermochemistry. So we can say that thermochemistry is the branch of physical chemistry which deals with the thermal or heat change caused by chemical reactions. So thermochemistry basically deals with the thermal or heat change, which is caused by chemical reactions. Sorry. Therefore, the thermochemistry provides the basic or useful information regarding the bond energies. You know that whenever any new bond is formed, then energy is released, and whenever any bond is broken down, then energy is required for the breaking of the bond. So basically, a chemical reaction involves the formation of new bond by breaking down the old bond. So in case of the reactants, you should supply the energy to break the bond of the reactants. And whenever the reactants reacts with each other and forms a new compound, then it is accompanied by the evolution of energy. And the need change in energy may be evolution of heat or maybe absorption of heat. And such types of transformation it generally is the main topics of physical chemistry, and the branch of physical chemistry deals with such types of chemical transformation where the thermal or heat changes is caused by the chemical reactions. Okay, now let's move on. The basic definitions or terminologies that will help us to understand the thermochemistry. Number one is the heat of reaction or enthalpy of reaction. What is heat of reaction? The definition of heat of reaction is the amount of heat. It is the amount of heat absorbed or evolved when the reaction has taken place at constant pressure or at constant volume between the reactants. So let me recapitulate this again. Heat of reaction is the amount of heat which is absorbed or evolved when the reaction has taken place at constant pressure or at constant volume between the reactants. That means whenever any reaction takes place, if the reaction may be taking place at constant volume, or it may be taking place at constant pressure, whatever the case is, it may be occurring in a constant volume or constant pressure, whatever the case, it is not matter of fact. The matter of fact is that after completion of the reaction, there will be a certain amount of heat absorbed or certain amount of heat may be evolved. And this evolution or absorption of heat is known as the heat of reaction. This evolution or absorption of heat is known as the heat of reaction. So what is heat of reaction? Heat of reaction is the amount of heat which is absorbed or evolved when any chemical reaction takes place. The reaction may take place at constant pressure or it may take place at constant volume. Whatever the case is, whenever a chemical reaction takes place, it is accompanied by absorption or evolution of heat, and the branch of chemistry which deals with the amount of heat absorbed or amount of heat evolved is known as the heat of reaction. It's known as the heat of reaction. Okay, let's simplify the definition of heat of reaction. In a simple word, we can say that the heat of reaction is the amount of heat absorbed or evolved in a chemical reaction. In a simple word, we can say that heat of reaction is the amount of heat absorbed or evolved in a chemical reaction. Okay. The heat of reaction is also known as enthalpy of reaction, and enthalpy of reaction may be a positive sign or maybe it may be a negative sign. Depending upon the situation, it may be a positive sign or it may be a negative sign. Okay. So how does we can calculate the heat of reaction? We can calculate the heat of reaction by using the equation del H is equal to H product minus H reactant, or HP minus HR, where the del H is the amount of heat absorbed or evolved, and HP is the enthalpy of product, HR is the enthalpy of reactants, enthalpy of product and enthalpy of reactants. So if the enthalpy of product and enthalpy of reactant is same, then the heat change may be 0. If the enthalpy of reactant is greater than the enthalpy of product, then the heat change will be negative. That means it will be an exothermic reaction. If the enthalpy of product is greater than enthalpy of reactant, then it will be a positive value. That means it will be an endothermic reaction. So the new term came, exothermic and endothermic reaction. So what is exothermic and endothermic reactions? Let's look at the definition of exothermic reaction. The reactions which are accompanied by the evolution of heat energy are called exothermic reaction. For example, if you dissolve the detergent in water, it will produce a hot solution of detergent and water. Since the amount of heat increases, therefore it is known as exothermic reaction. And the endothermic reaction will be just opposite of the exothermic reaction. In case of exothermic reaction, the enthalpy of reactant is greater than the enthalpy of product. That is why it generally brings a negative sign. And in case of endothermic reaction, the reactions which are accompanied by the absorption of heat are called endothermic reaction. For example, if you dissolve glucose in water or ammonium chloride in water, then the temperature of the solution decreases, and this is known as an endothermic reaction. Now let us discuss about exothermic and endothermic reaction in details. Let us consider a reaction where the reactants are A and B. They are reacting with each other and producing C and D. So A and B are the reactants and C and D are the products. Now let us consider that the enthalpy of the reactants are H subscript A, H subscript B, and the enthalpy of the products are H subscript C and H subscript D. Now, according to the equation, the heat of reaction or enthalpy of reaction will be represented by del H, and del H is equal to the differences between the enthalpies of products and reactants. That means del H is equal to enthalpy of product minus enthalpy of reactants. Here the enthalpy of products are HC plus HD minus the enthalpy of reactants are HA and HB. Now, if the enthalpy of product and enthalpy of reactants are equal, then the overall change in heat or heat of reaction will be 0, or enthalpy of the overall enthalpy of the reaction will be 0. But if the enthalpy of product is, let me show you a diagram. If the enthalpy of product has a higher energy value, but the enthalpy of reactant has a lower energy value, then what will happen? Then the enthalpy of product will be if the enthalpy of product has a higher energy value and enthalpy of reactant has a lower value, then the heat of reaction will have a positive value. That means it will be an endothermic reaction. On the other hand, if the energy or enthalpy of reactants is greater, the enthalpy of reactants or energy value or enthalpy value of reactants is greater, and the energy value or enthalpy value of product is lower, then what will happen? Then there will be a negative sign. That means the overall heat of reaction will be a negative value, will have a negative value, that indicating that it is an exothermic reaction. It will be an exothermic reaction. So when the enthalpy of reactant is greater than the enthalpy of product, reactant is greater than enthalpy of product, then the overall sign will be a negative sign and it will be an exothermic reaction. On the other hand, if the enthalpy of product is greater than enthalpy of reactant, then it will have a positive sign and the reaction will be regarded as an endothermic reaction. So let us restate the definition of exothermic reaction. According to the definition, exothermic reactions are those reactions which are accompanied by the evolution of heat energy. And endothermic reactions are those reactions which are accompanied by the absorption of heat energy. Some example of exothermic reactions are making of ice cubes. Endothermic reaction is melting of ice cube. Exothermic reaction, burning sugar. Endothermic reaction, baking bread. Exothermic reaction, nuclear fission. Endothermic reaction, melting solid salts, etc., etc. And the sign for the exothermic and endothermic reaction will be different. And when the enthalpy of reactants is greater than enthalpy of product, then the sign will be a negative sign, indicating that this is an exothermic reaction. And when the heat of enthalpy of product is greater than enthalpy of reactant is greater, then the enthalpy change will have a positive sign and it will be regarded as an endothermic reaction. Hope you have understood the endothermic and exothermic reactions. There are different types of heat of reaction or enthalpy of reaction. Let us discuss some of them. Number one is heat of formation. As the name suggests that there will be a heat change when the heat change will occur. According to the name, we can assume that the heat change will occur during the formation of new elements or during the formation of new compound. So if we define heat of formation, we can say that heat of formation is the change in enthalpy that takes place when 1 mole of a compound is formed from its elements. So 1 mole of a compound is formed from its elements. And when this happens, there will be a change in enthalpy or change in temperature. And this change of temperature is regarded as heat of formation. This change of will be regarded as heat of formation. For example, let us consider the formation of ferrous sulfide or ethylene. When ferrous sulfide is formed from the reaction between ferrous and sulfur, then there is a change in heat, and the amount of heat change is minus 24 kilocalorie. So this is an exothermic reaction, and this value of minus 24.0 kilocalorie is the heat of formation. For whom? For the formation of ferrous sulfide. In the similar manner, let us consider the formation of ethylene. In case of ethylene molecule, it is formed by the reaction between the carbon and hydrogen. When 1 mole ethylene is formed by the reaction between carbon and hydrogen, then the amount of heat absorbed is plus 53.14 kilocalorie. So therefore, the production or formation of 1 mole of ethylene absorbs 53.14 kilocalorie heat. So the heat of formation for ethylene molecule is 53.14 kilocalorie. So I think you have understood what is heat of formation. In the similar manner, when 1 mole hydrochloric acid is formed by the reaction between hydrogen and chlorine, and the amount of heat evolved during the formation of 1 mole of hydrochloric acid is minus 44.0 kilocalorie. So the heat of formation in case of hydrochloric acid is minus 44.0 kilocalorie. So this is the heat of formation. And let me recapitulate the main point again. Heat of formation is the amount of heat absorbed or amount of heat evolved when 1 mole of the compound is formed from its elements. 1 mole of a compound is formed from its element. So this is known as the heat of formation. Okay. Our next definition is standard heat of formation. Standard heat of formation. So what is standard heat of formation? It is also heat of formation. It is of course heat of formation, but here the heat of formation will take place in a standard condition. The heat of formation will be taking place in a standard condition. So we can say that the change in enthalpy that takes place when 1 mole of a compound is formed from its element when all substances be in their standard state. This is the difference between the heat of formation and standard heat of formation. In case of heat of formation, only the change was accounted which taken place when 1 mole of a compound is formed from its element. But in case of standard heat of formation, the heat change or enthalpy change that takes place when 1 mole of a compound is formed from its element, when all the substances, both the reactants and products, are being in their standard state. Here, the standard state indicates that 298 Kelvin and 1 atmospheric pressure. That means 25 degrees Celsius temperature and 1 atmospheric pressure. So when 1 atmospheric pressure and 25 degrees Celsius temperature is maintained, then the heat change that takes place when 1 mole of a substance or 1 mole of a compound is formed from its element will be regarded as standard heat of formation. For example, the standard heat of formation in case of water is minus 57.84 kilocalorie per mole. In case of methane, minus 17.89 kilocalorie per mole. In case of benzene, plus 11.86 kilocalorie per mole. So I think you have understood how is standard heat of formation. It is just heat of formation which occurs in standard condition. That means the standard condition indicates that it should be the reaction condition or the reaction should be taken place at 25 degrees Celsius and 1 atmospheric pressure. That is the basic difference between the heat of formation and standard heat of formation. Okay. Now let's move on our next definition, which is heat of combustion. So what is heat of combustion? As the name suggests, it is the heat change during the combustion. So we can say that the change in enthalpy of a system when 1 mole of substance is completely burned in excess air or oxygen. That means whenever you are burning a substance, if it is 1 mole of a substance, if you are burning 1 mole of a substance and you have completely burned this 1 mole of substance in excess air or oxygen, then the change in enthalpy of the system will be the heat of combustion. Will be the heat of combustion. Will be the heat of combustion. Okay. So what is heat of combustion? I have already told you what is combustion. According to the definition, when we burn methane, we're burning this methane in excess amount of oxygen, in presence of excess amount of oxygen, and after complete burning, we are burning 1 mole. This is suppose this is 1 mole of methane. We are burning this 1 mole of methane in excess amount of oxygen. After complete burning, the heat change is minus 21.0 kilocalorie. So after this will be regarded as heat of combustion because this amount of heat is produced when 1 mole of methane is completely burned with oxygen. 1 mole of methane is completely burned with oxygen in the presence of excess air or oxygen, and this burning has produced minus 21.0 kilocalorie heat. So the heat of combustion for methane is minus 21.0 kilocalorie. In the similar manner, if you burn carbon dioxide or only carbon, suppose you are burning carbon in excess oxygen, burning of carbon will produce carbon dioxide, and after complete combustion, the heat change is minus 94.3 kilocalorie. So the heat of combustion for 1 mole of carbon is 94.3 kilocalorie. And you can see that the heat of combustion has all these three heat of combustion has a common common feature that they have a negative value. This is also a negative value. This is also a negative value, and this is also a negative value. So we can say that the heat of combustion of a substance is always a negative value. Heat of combustion of a substance is always a negative value. It has a negative value. I think you have understood heat of combustion. Now, what is heat of solution? As the name suggests, you can see that this is the heat sense whenever a solution is produced. That means if you completely dissolve any 1 mole of a substance into a specific solvent, then after complete dissolution, the amount of heat sense will be regarded as heat of solution. The amount of heat sense will be regarded as heat of solution. So what is heat of solution? The change in enthalpy when 1 mole of a substance is dissolved in a specific quantity of solvent at a given temperature. That means if you dissolve 1 mole of a substance, if you dissolve 1 mole of a substance in a specific quantity of solvent at a given temperature, then the amount of change in enthalpy will be regarded as heat of solution. Will be regarded as heat of solution. So what is heat of solution? The change in enthalpy when 1 mole of the substance is dissolved. Suppose you are dissolving a substance. If the substance is 1 mole, and after you are dissolving the substance in a specific quantity of solvent and at a particular temperature. So maintaining a particular volume of solvent and particular temperature, if you completely dissolve 1 mole of a substance, then the amount of heat change that occurred after complete solubilization will be regarded as the heat of solution. Will be regarded as heat of solution. Let us say, look at the example. Suppose you are dissolving potassium chloride in water at a particular temperature and particular volume of water. You have taken particular volume of water, and and the solubilization is taking place at a particular temperature. After complete dissolution of potassium chloride in the water, this was the solid potassium chloride, and after complete dissolution, it has converted into, you can see that this is solid potassium chloride, and this is aqueous potassium chloride. And after complete solubilization, the heat change is minus 4.4 kilocalorie. So the solubilization of potassium chloride in water in a particular volume of water and particular temperature produced minus 4.4 kilocalorie. So this value of 4.4 kilocalorie will be regarded as the heat of solution. Will be regarded as the heat of solution. I hope you have understood what is heat of solution. Now our next topic is heat of utilization. As the name suggests, it will be a utilization reaction. That means the reaction between an acid and a base. The reaction between acid and base is regarded as neutralization reaction. So when 1 gram equivalent of an acid is neutralized by 1 gram equivalent of base, or you can say that when 1 gram equivalent of base is neutralized by 1 gram equivalent of acid, then there will be a change in temperature, and the change in the temperature or heat of the system is known as the heat of utilization. It's known as the heat of utilization. So what is heat of utilization? Heat of utilization is the change in heat content or enthalpy of the system that takes place when 1 gram equivalent of an acid is utilized by 1 gram equivalent of base, or the change in heat or enthalpy that takes place when 1 gram equivalent of base is utilized by 1 gram equivalent of acid in a dilute solution. In a dilute solution, this is a particular requirement. The solution should be a dilute solution. Okay. I hope you have understood what is heat of utilization. Now let's take some example of heat of utilization. Look at the example. In the example, you can see that 1 gram equivalent of nitric acid reacts with 1 gram equivalent of sodium hydroxide. This is acid and this is base. After utilization, they produces salt and acid, sodium nitrate and water. And the heat change after completing the reaction is minus 13.6 kilocalorie. So heat of utilization for the utilization reaction between sodium hydroxide and nitric acid, between nitric acid and sodium hydroxide is 13.69 kilocalorie, and this is the heat of utilization. Since the utilization reaction basically takes place between the hydroxyl and hydroxyl ion, we can build up a general reaction representing an acid and base. Suppose this is an acid and this is a base, and it will be neutralized and ultimately will produce a salt, and the salt will also be dissociated in the solution, and it will also produce water. And basically the neutralization reaction takes place between the acid and the base, but acid will furnish or will liberate hydrogen ion, and base will liberate hydroxyl ion. This hydrogen and hydroxyl ion will produce water, and the cation or anion part of acid and base will produce salt, and the salt will be dissociated in the water. So we can generalize the equation like this, and this is the change in heat, change in the neutralization reaction, and this will be regarded as heat of neutralization. I hope you have understood what is heat of neutralization. Now our next topic is heat of fusion. Heat of fusion. What is heat of fusion? Fusion means what? Fusion means melting. Fusion means melting. So whenever melting takes place, for example, solid ice will be melted into liquid water. Melting of solid ice into water will cause some change in the heat, and this type of heat change is known as heat of fusion. So what is heat of fusion? Heat of fusion is the heat change that takes place when 1 mole of a solid substance, this is a solid substance, 1 mole of a solid substance, ice is a solid substance. When 1 mole of a solid substance is converted into the liquid state at its melting point. At its melting point. The melting point of ice, we know that the melting point of ice is 0 degrees Celsius or 273 Kelvin, and this will be regarded as the heat of fusion. The amount of heat absorbed for the melting of ice into water required is plus 1.43 kilocalorie. So this is the heat of fusion. So what is heat of fusion? The amount of heat required to melt the solid 1 mole of solid substance into its liquid state at its melting point. So water took 1.43 kilocalorie of energy and melted from the solid state, that means ice, into the liquid water state at 0 degrees Celsius. So 1.43 kilocalorie is the heat of fusion for water. Like the heat of fusion, heat of vaporization is also the amount of heat required to evaporate 1 mole of the substance into its vapor state or gaseous state at its boiling point. For example, water boils at 100 degrees Celsius or 373 Kelvin. So water evaporates at 100 degrees Celsius temperature or 373 Kelvin, and whenever the liquid water, this is the liquid water that converts into water vapor, 1 mole of liquid water is converted into its water vapor. at 100 degrees Celsius temperature or 373 Kelvin temperature, and the amount of heat absorbed is plus 9.71 kilocalorie. So 9.71 kilocalorie will be regarded as the heat of vaporization. 9.73 is the heat of vaporization. Okay. So what is heat of vaporization? The heat change or enthalpy change when 1 mole of liquid, for example, 1 mole of water is converted into vapor or gaseous state. 1 mole of liquid water is converted into water vapor. In which temperature? At its boiling point, and the boiling point of water is 100 degrees Celsius temperature. So when liquid water is converting into water vapor at 100 degrees Celsius temperature, it will absorb 9.71 kilocalorie temperature, 9.71 kilocalorie heat energy, and this is the heat of vaporization for water during the conversion of liquid into the vapor state. Hope you have understood heat of vaporization. Now let's move on. Heat of sublimation. As the name suggests, it is the heat change that takes place when 1 mole of a substance is directly converts from its solid state into the gaseous state. For example, 1 mole of iodine is converting into 1 mole of solid iodine is converting into its gaseous iodine or iodine vapor. 1 mole of iodine is converting into iodine vapor below its melting point, and the amount of heat required for the conversion of solid iodine into the iodine vapor is plus 14.92 kilocalorie. So 14.92 kilocalorie is the heat of sublimation that is required for the conversion of iodine from its solid state into the gaseous state. Okay, now let us define what is heat of sublimation. Heat of sublimation is the heat change or enthalpy change when 1 mole of a solid is directly converted into its gaseous state at a temperature below its melting point. So whenever a solid that converts from its solid state into the gaseous state below its melting point, then the amount of heat absorbed by the solid is known as heat of sublimation. In case of iodine, the heat of sublimation is 14.92 kilocalorie. So this is the heat of sublimation for iodine. Hope you have understood what is heat of sublimation. And this is our final term, today's final term. This is heat of transition. What is heat of transition? As the name suggests that, the name is quite self-explanatory. Transition means changing from one form to another form. So we can say that whenever 1 mole of a substance or element changes from its one allotrope to another allotrope, then the amount of change in the heat or enthalpy is known as heat of transition. So what is heat of transition? Heat of transition is the change in enthalpy which occurs when 1 mole of an element changes from its one allotropic form to another allotropic form. For example, whenever monoclinic sulfur, this is the monoclinic sulfur, changes into the rhombic sulfur, then minus 0.016 kilocalorie temperature evolves, and this change in temperature will be regarded as heat of transition. In the similar manner, when 1 mole of diamond, solid diamond, changes from its one allotropic form, diamond form, into the amorphous form. That means whenever the carbon atom, basically whenever the carbon atom, when the carbon atom changes from its diamond allotrope or a diamond crystal structure into amorphous crystal structure, then plus 3.3 kilocalorie temperature is required. So the change in this temperature, will be regarded as the heat of transition in case of the conversion of carbon from its diamond to amorphous crystal structure. So I think you have understood the different types of heat change, and that's all for today's lecture. Thanks to all for listening.